Hello dear students, today we are going to study the solution and colligative property. So first part is the introduction. In introduction we have some general knowledge based question or some memory based question. For example, the expected question in the exam, the composition brass is the mixture of copper and zinc. Similarly, the composition of German silver, copper, zinc and nickel. So question number 1 expected on the brass, there's a mixture of copper and zinc. Number 2, the German silver, that is a composition of copper, zinc and nickel. Similarly, third question is the bronze, that is a mixture of copper and tin. Bronze, copper and tin. Similarly, the fourth question, what is the 1 parts per million fluoride ion prevent the tooth decay? So the fourth expected question, fluoride ion prevent tooth decay. But if we increase the concentration greater than 1 ppm, then tooth mottled. If the concentration is greater than 1.5 ppm, then tooth mottled. Even more high concentration, very high concentration, is the poisonous compound. For example, sodium fluoride is found in the rat poison. For example, sodium fluoride is found in the rat poison. Similarly, intravenous injection, IV injection, are also very good solutions of the salt to maintain the equal concentration of iron with respect to blood plasma. So these are the introductions GK based question. Let's summarize once more. The brass is the mixture of copper and zinc. German silver is the mixture of copper, zinc and nickel. One question is asked in the exam like AIEEE, that is what is the percentage of silver in German silver? So answer is the 0%. Next question is the bronze. The bronze is mixture of copper and tin. Fluoride ion is present in toothpaste that prevent the tooth decay. But if the concentration of fluoride ion is greater than 1.5 ppm, then tooth mottled. Similarly, what we have, the NAF is the rat poison, and intravenous injection has concentration equal to blood plasma. Let's start on the detail. What is the solution? Solution is nothing but homogeneous mixture of two or more than two components. Now as we know, solution is made up of two component known as binary solution, three component ternary solution, four component quaternary solution. Similarly, we have two different part. One is the solute and second is the solvent. Now, based on definition, we can say that solution and solute are in different phase, are in different phase, but solution and solvent are in same phase, are in same phase. Means what? Suppose that we have the concentrated sugar syrup solution. Suppose that we have the concentrated sugar syrup solution. Here the concentration of sugar is high and solvent is low, but it appears like a liquid and water appears like a liquid. So liquid and liquid means same phase. Liquid and liquid means same phase. Another definition is the condition if both solute and solvent are in same phase. If both solute and solvent are in same phase, then only we decide with amount of substance. We decide with amount of substance. If the amount of substance is low, then it is solute, and if the amount of substance is high, then it is solvent. So first definition preferred first. It is the based on the different phase. What was the condition? Condition was different phase. In that condition we say that if solution appears like a liquid and solvent appears like a liquid, means solution and solvent are in same phase. Another condition is that if they are in same phase, in that condition we differ our solute and solvent in term of amount. The solute is always present in less quantity, and solvent is present in more quantity. For example, if we say I have the 5% ethanol, means I have 5% ethanol by mass, means I have 5 gram ethanol and 95 gram water, so that total becomes 100 gram solution. Now this is also liquid and this is also liquid, means condition if all are in same phase. In that case the component present in less quantity is called as solute and component present in high quantity is called as solvent. So let's move to the next topic of NCERT, that is the type of solution. Now according to NCERT, solutions are homogeneous mixture of two or more than two component. Solutions are mixture of two or more than two component. Homogeneous mixture means they are uniform in composition. Means what? Suppose that I am explaining here Suppose that this is a glass and it has two straw. It has two straw. One person is drinking it from here, drinking from it here, and second person is try to drinking from this level, and this is the uniform composition. So the quality, the taste, the composition, the concentration achieved by first person and quality concentration achieved by the second person, both are getting the same. We cannot say that upper layer has different concentration and lower layer has different concentration. No. If this happen, in that case it is heterogeneous. This and this, all composition are same. All compositions are same. Therefore, the solution which is uniform throughout is called as homogeneous solution. Homogeneous solution. Such solution cannot be separated by simple physical method. Such solution cannot be separated by simple physical method, like you can say filtration, sedimentation, crystallization, etc. So simply by referring NCERT we can say that homogeneous solution या homogeneous mixtures are the composition and property uniform throughout. So the component present in large quantity is called as solvent, but this condition apply when both are in same phase only. If they are not in same phase, they are in the different phase, then we have to use phase difference, means solution and solvent are in same phase. So in our syllabus we have binary solution. Now binary solution have two component. One is the solute. Binary solution has two component. One is the solute and second is the solvent. So here some again memory based question, example based question expected in the exam. Again what we have, the memory based question. For example, if solute is gas and solvent is gas, example of mixture of O2 and N2. Similarly, solute chloroform CHCl3. Chloroform CHCl3 present in nitrogen gas. Similarly, we have the camphor, kapur, we used in the puja. Camphor in the nitrogen gas are the example of solid in gas. So all the solvent are in gas phase and solution also appear in the. Therefore I say the solvent and solution has the same phase, but solvent is gaseous. Solvent is always gaseous. But in the case of solute, it may be gas, it may be liquid, it may be solid. Therefore, we are defining the solution by this term, that In the case of different phase, solution and solvent are in same phase. Solution and solvent are in same phase, but solute may be in the different phase or maybe in the same phase. Similarly, here we can say that liquid solution has liquid solvent. For example, if the component is gas, then oxygen gas. If the component is liquid, then we can say that ethanol. If the component is solid, then we can say glucose. And here the universal solvent, that is the water. So solute may have different phase. Solute may have, the gas is the oxygen gas, the liquid is the ethanol, and the solid is the glucose. Similarly, if we carry the another term, solid solution. So as we know by definition, what we have, the solvent in the same phase. Solvent in the same phase. Solvent and solutions are in same phase, but solute is in different phase or maybe in the same phase. For example, if the solute is hydrogen gas, if the solute is mercury, and if the solute is copper, dissolve in solvent palladium, sodium and gold. So these are the example based question to understand the different kind of total 9 types of solution. Now we are moving the main terms from where the questions are demanded in the exam, that is expressing the concentration of solution. Means what? Suppose that you are preparing a food and in first row 5 people are here. Five people are here. 1, 2, 3, 4, 5. They are getting the good quality of food. Now in the second row, in the absence of food, what the chef do? He mix the water. He mix the water in vegetable. In vegetable. So the first row is getting the good quality of food. So in the term of chemistry, we will say it is the concentrated. And in second row, it will go due to addition of water. So we say it diluted food. So this is the qualitative measurement. This is the qualitative measurement. That is the concentrate or not concentrate. To quantify it, for quantitative, we have to use different terms. And these terms are divided in the two category. One is the temperature dependent, and second is the temperature not dependent. One is the temperature dependent and second is the temperature not dependent. For example, percentage by mass, molality, molality, mole fraction, mass fraction, these terms are not dependent on temperature, while the temperature containing volume, temperature related with the volume, because volume change with temperature, so they are dependent on temperature. Like we said that percentage by volume, molarity, normality, formality in such terms, percentage V by V or W by V, both. These terms are dependent. So this is also expected question in the exam. It may be the NEET or maybe the JEE or maybe your board MCQ questions. So you have to focus on these terms. Which terms are the temperature dependent, which terms are temperature not dependent. Let me explain one by one in detail. So what is our first term? That is a percentage by mass. This is the mass of component in solution divided by total mass of solution. We can simply say that percentage W by W is equal to W1 divided by W1 plus W2. If it is binary, or you can into 100, you can say that W1 into 100 divided by W1 plus W2 plus W3 if it is ternary. Now simple meaning of, what is the meaning of 10% glucose in water? 10% glucose in water. We can simply say that what we have, 10% glucose in water. What we know, the percentage has maximum composition, maximum quantity, that is 100. That is 100. So we can say that mass of solution is equal to 100 gram. Now as we know how to calculate the percentage, 10% means 100 into 10 divided by 100 is equal to 10. So mass of solute glucose is equal to 10 gram. As we know, mass of solute plus mass of solvent is equal to mass of solution. So mass of solution is 100 gram, mass of solute is 10 gram. So mass of solvent X is equal to 100 minus 10 is equal to 90 gram. We can do this calculation because we know that mass is an additive property. Mass is an additive property. So by this way we can say that 10% glucose contain 10 gram glucose dissolved in 90 gram water to make the 100 gram solution. So why we have to study this composition? Because they have industrial applications. For example, commercial bleaching powder CaOCl2, commercial bleaching powder contain 3.62 mass percent of sodium hypochlorite in water. Sodium hypochlorite, my mistake, NaOCl, sodium hypochlorite, NaOCl. This is the, and that is CaOCl2 is the bleaching powder, and this is the commercial bleaching solution that contain 3.62 mass percent of sodium hypochlorite in water. So similarly, if we have to consider, suppose that we have approximately 5% urea by mass, means what? What will be mass of solute? 5 gram. What will be mass of solution? because it is the percentage, so it will be 100 gram. And what will be mass of solvent? As we know, solution is equal to solute plus solvent, so it is 95 gram. Similarly, if we say we have the 15% cane sugar by mass, in that case mass of solute becomes what? 15 gram, but percentage maximum quantity remains 100 gram, so this quantity becomes 85 gram. By this way we can assume the numericals. Suppose that we are taking one numerical on percentage mass, on percentage mass. Let's take an example. Suppose that we have the question number 1 for the mass. If 3.42 gram cane sugar is mixed with solvent to prepare 100 gram solution, then find percentage by mass of cane sugar, In such question we can say that what is the given data? Mass of solute is equal to 3.42 gram and mass of solution is equal to 100 gram. Percentage by mass have formula, that is the mass of solute divided by mass of solution into 100, that is equal to 3.42 gram given here into 100 from here and divided by 100. So the answer becomes 3.42% by mass. So by this way we can solve the questions. For example, if we have another question, if 2 gram of substance A mixed with 18 gram of substance B, then find percentage by mass. Similarly we can say that formula percentage by mass is equal to WA divided by WA plus WB total into 100. According to value it becomes 2 into 100 divided by 2 gram component A and 18 gram component B. So 2 into 100 divided by 20. We have to find the percentage mass of component A. In that case, it becomes 10%. In that case, it becomes 10%. So such kind of question may be asked in the exam like CET or Maharashtra board, but in JEE or NEET little bit higher level is expected. Let's watch on that numericals. So the second term is, okay, now this term is divided by mass, so we can say that it is temperature not dependent. This term is temperature not dependent. Now the second term is percentage V by V. Percentage V by V. So in here we can say that percentage V by V is equal to volume of solute divided by volume of solution into 100. As we know, mass is an additive property, but volume is not an additive property. Not an additive property. In that case, volume of solution may or may not be equal to volume of solute plus volume of solvent. So writing the question like that, volume of solute into 100 divided by volume of solute plus volume of solvent may not help in the exam. So never use this formula, because volume is not a additive property. Detail we will explain this in the Raoult law. Some solution 100 ml plus 100 ml, some solution becomes 200 ml, some solution becomes more than 200 ml, and some solution becomes less than 200 ml. It depends upon the vapor pressure. So we will discuss later. But never try to found the solution in this way. If the density is given, then from volume of solute you can calculate mass of solute by using density of solute. From volume of solvent by using density of solvent you can calculate mass of solvent. From mass of solvent you can calculate mass of solution. And again, if density of solution is given, then you can calculate volume of solution. But direct approach to calculate the volume of solution is not preferred in the exam. So let's focus. Similarly, by mass we have the term by volume. By volume. Suppose that I have 2% glucose, 2% ethanol in water. It means V by V, percentage V by V. It means volume of ethanol is 2 ml. Volume of solution is 100 ml. But never conclude volume of water is equal to 98 ml. This will be wrong, because volume is not an additive property. So let's focus on NCERT. What we have, the 10% ethanol solution in water. It means what we have, 10 ml ethanol dissolve in such that total volume of solution becomes 100 ml. So again we have some point to memorize. 35% volume of ethylene glycol is an antifreeze. This question may be expected in CET level exam, but not in NEET and JEE, because the memory based question is not too much weightage in the competition. But in the board exam or CET exam, we can say that. Now here it is written that it is used as cooling for car engine. It lower the freezing temperature by minus 17 degrees Celsius. Later we will study that how it happens, but till that you have to think on that concept. Means if pure water, what we have, pure water has boiling point 100 degrees Celsius and melting point, freezing point 0 degrees Celsius. If we add some salt, means if we make solution, by adding some salt plus pure water, then normally boiling point becomes more than 100, and freezing point becomes less than 0 degree Celsius. So suppose that here in the cold countries we have ice layer and ice freeze at 0 degree Celsius. Now avoid use of JCB and try to sprinkle the salt. As we know, salt water has freezing point less than 0 degree Celsius. Suppose that minus 5 degree Celsius. Means at 0 degree Celsius this salty water is in liquid phase, because at minus 5 degree Celsius it will be in the solid phase, and at 0 degree Celsius it will be in the liquid phase. So in cold countries they are avoiding the use of JCB and try to sprinkle the salt on ice so that ice melt easily by lowering the freezing point. Detail we will study this in the next after 2 class. So if suppose that you have given percentage volume by volume type numerical, so again we can say that if suppose that I have the question, a 2 ml ethanol is dissolved in solvent to obtain a final volume of solution 50 ml, then find percentage V by V. In such case the formula will becomes V1 divided by volume of solution into 100. So 2 upon 50 into 100. So answer will be 4% V by V. Answer will be 4% V by V. Here we have the 35% ethylene glycol. V by V glycol. It means we have 35 ml glycol and 100 ml solution. But if someone say 100 minus 35 ml solvent, is equal to water, then this calculation will make a mistake. We never calculate because volume is not an additive property. So these two are correct, but this is not correct. Keep in mind. Now, if we have the term by volume, then in mind we got two different data. One is the percentage V by V and second is the percentage W by V. Normally, if in question nothing is explained about the term, then we will prefer this W by V. Until unless percentage V by V is provided in data, we will not use it. So if it is given in question that we have to use percentage by V, percentage V by V, then only we have to use this. Otherwise we have to prefer W by V, mass by volume. So percentage by volume have another percentage mass by volume. So normally these terms are used in the medicine and pharmacy. So it have the formula percentage by volume is equal to mass of component that required solute divided by volume of solution. Writing the solute plus solvent will be incorrect. So don't write in this way. Percentage by volume. Now another point is parts per million. To understand this, suppose that we have here 100 particles and 1 particle is here and 99 particle is here. Then the concentration becomes 1 out of 100, and that what we define in term of percentage. But if here is the 1000, 1 particle here and 999 particle here, then it is called 1 out of 1000. In such case we call parts per thousand. If it is 10,000, 1 particle is here and 999 particle is here, this is the 1 out of 10,000. So we call it parts per 10,000. We say parts per thousand, we will say parts per 10,000. In similar, if it is 10 raised to power 6, then it is called parts per million. Similarly, 10 raised to power 9 parts per billion. So number of parts of component and number of parts of total component into 10 raised to power 6 is say ppm. Just like 100 is the percentage, at 10 raised to power 6 is the ppm. So we have to study these minute concentrations. For example, when you study the sea water, you observe that 6 into 10 raised to power minus 3 gram oxygen is dissolved. So such a small concentration, we can also measure the concentration of pollutant. So two ways to return. One is the 10 raised to power minus 6 gram per ml, or we can use say ppm. So we will, in chemistry we will prefer the concentration term mu g divided by ml. Mu g divided by ml. Now another term is the mole fraction. So as we know the fraction like this fraction is the 1 by 4. Suppose that an student have total marks 600 and he obtained 500. In that case, we can say fraction of marks is equal to 500 divided by 600. Like pizza, we can say that 1 by 4. So this is the simple calculation we studied in the 5th class. So we have the binary solution. So two component. One component is the A and second component is the B. Now in that case, if we will talk about the mole fraction of first component, so the formula becomes moles of first component divided by moles of first component plus moles of second component. As we know, the binary solution has two component, component A and component B. So XB is equal to what? NB divided by Na plus Nb. And as we know, sum total of fraction is always equal to 1. So we can say that XA plus XB is equal to 1. So by using this formula, and N is nothing but mole, and you can remember the formula, weight in gram, mass in gram divided by molecular mass in gram per mole. So by using these formula, we can calculate the questions of mole fraction. Because mole fraction is the division, so it is always unitless and independent on temperature. Its value does not change with the temperature. Another term is the molarity. So molarity is nothing but, suppose that we have the term 5 molar glucose, and as we know, the molarity is nothing but moles of solute divided by volume of solution in liter. And can we divide 5 upon 1? By comparing the data, we can say that here the moles of solute is equal to 5, and we can say that volume of solution is the 1 liter. Volume of solution is equal to 1 liter is equal to 1000 ml. And as we know, from mole we can calculate the mass of solute. Glucose C6H12O6, molecular weight 12 into 6 72, 1 into 12 12, and 16 into 6 96, becomes 180. So multiply by 180. So we can say that if it is 5 mole, then it is 9000 gram. Clear? So this is a hypothetical data. Don't confuse about the 100 ml water and 9. It is just a imaginary question. So one more time, if you want to explain, Suppose that I have to 0.1 molar urea. Urea having formula you know, NH2CONH2. So we can say that molarity is equal to moles of solute divided by volume of solution, and we can say that it is 0.1 divided by 1. From this data we can say that moles of urea is equal to 0.1, and from this data we can say that volume of solution in liter is equal to 1 liter is equal to 1000 ml. Now this compound have the molecular mass 60 gram per mole. So from here we can calculate the mass of urea. We know mole is equal to mass upon molar mass. Mass upon molar mass. So mole value is 0.1. Mass we have to find, and molar mass is 60. This term will go and multiply. So mass of urea becomes 6 gram. So by this way we can calculate the question. Suppose that a question is given here. Calculate the molarity of NaOH. Calculate the molarity of NaOH. If we have 4 gram NaOH, 4 gram NaOH in water, enough to make 250 ml solution. Enough to make 250 ml solution. As we know, the formula of molarity is equal to moles of solute divided by volume of solution in liter. Now mole is equal to mass divided by molar mass. Now NaOH 23, oxygen 16 plus hydrogen 1 is equal to 40 gram per mole. And here the mass is given 4 gram. So 4 divided by 40 is equal to 0.1. Volume of solution is 250 ml, means 0.25 liter. So here the moles of solute is 0.1 and volume of solution is 0.25. Now we can say that it is 10 upon 25. So the answer becomes 0.4. Unit becomes mole per liter. Mole per liter. Now some conversions are there. 1 liter is equal to 1 dm cube. So we can say that 0.4 mole per dm cube. So this will be right answer. Now in the molarity we have the denominator, what is the volume, and volume change with the temperature. So molarity will also change with temperature. Molarity will also change with temperature. So this is the term molarity. Now if we want to understand this term, 0.25 molar NaOH In that case, we can say that 0.25 mole NaOH is present in 1 liter solution. 1 liter solution. Now, in term of molarity, we have two different terms. As I said, volume change with the temperature. So yes, molarity changes with temperature. Now some terms are there. Do you know what is the standard solution? What is the standard solution? The solution whose molarity is known. The solution whose molarity is known is called as standard solution. Second term, do you know what is the stock solution? So we can say that solution of desired concentration, solution of desired concentration prepared by diluting the concentration of standard solution, means known concentration solution. Standard solution is called as that known higher concentration, that known concentration means it has higher concentration. Means what? Suppose that I have a solution of 3 molar and I have some students. I will put 1 ml in each. 1 ml in each and add 9 ml water. So this was the standard solution. This was the standard solution. Now we are using these solutions. So this higher concentration solution is also known as stock solution. Stock solution, you know, stored solution, for preserved solution, for long term use. So we are mixing here the water. So sometime the questions come on the law of dilution. Sometime the question comes on law of dilution. Suppose that I am mentioning here law of dilution. Such questions comes in the JEE and NEET. Now the logic behind that. Suppose that we have 5 particle, 1 2 3 4 5. Suppose that we have 5 particle. Up to this concentration, and if I am adding water and I have 1 2 3 particles, suppose that after adding water, we have the increased level of the water level. This is the water level previous. This is the water level final. But what do you think? The solute particle was 3. What happens? It becomes 3 or it becomes 6 or something change? Yes, you are thinking right that the number of particle will not change. Here is the 3 particle before mixing water or before dilution, and even after adding water again it is 3 particles after dilution. So if any number divided by Avogadro number, then we can say mole. Mole before dilution is equal to mole after dilution. And as we know, molarity is equal to moles upon volume. So molarity is equal to moles upon volume. So mole is equal to molarity into volume. In such case, we can say that MIVI, M initial, molarity initial, volume initial, is equal to M final, V final. I means initial and F means final. So by using this case, we can solve the questions of dilution. Similarly, we can solve the questions of mixing also. Suppose that we have the questions of law of mixing of same component, of same solution. Law of mixing of same solution. Suppose that in any beaker, if we have the 5 particle of NaOH, 5 particle of NaOH. In another beaker, we have 15 particle of NaOH. After mixing, what happen? Yes, it becomes 20 particle of NaOH. So number plus number is equal to final number. Number divided by Avogadro number is called as mole. So we can say that mole of first condition plus mole of second condition is equal to mole of final condition. So here we can say that M1 V1 plus M2 V2 is equal to M final V final, where V final is equal to V1 plus V2 plus volume of water if added. If not added, then it is V1 plus V2. If not added, then it is V1 plus V2. If diluted further, then volume of water must be added. So next term is the molality. Molality is the temperature not dependent, because here is the mass. As we know, the molality we can say that moles of solute divided by mass of solvent in kg. Please do not confuse with the term molarity, that is the moles of solute divided by volume of solution in liter. Try to remember the term. This is the solvent and this is the solution. Another difference, this is the mass and this is the volume. It is denoted by the small m and this is denoted by the capital M. So volume therefore temperature dependent and mass therefore temperature not dependent. So these are two different terms. So in the board exam, lot of time this question was asked: mass percentage ppm mole fraction and molality are independent of temperature. This is the very standard famous line. Mass percentage, ppm, mole fraction, molality are temperature independent, whereas molarity is a function of temperature. This is because volume. But along with molarity, yes, we have percentage by volume.